Alright, greetings everyone. So today we are going to go into another part of your redox reaction, alright, which is about the rusting of your iron. Okay, so for today I'm going to focus on two things. One is on how rusting happens, okay, the mechanism of rusting, and second will be how can we control the rusting process. Meaning if I want to prevent rusting from happening, what can I do? Alright, so before we go into the mechanism, okay, what I call an introduction, okay, a very short introduction of the meaning of rusting. Alright, so basically, what we are learning here is that metals, okay, when they undergo oxidation, they are going to release electrons. Alright, if you remember your electrochemical series, right, the one on top is more electropositive, so they are going to undergo oxidation. Okay, so when metal undergoes oxidation, right, this is what we call corrosion. Alright, so remember when we say the term corrosion of metal, meaning that the metal is undergoing oxidation. So these are the examples, okay? So if we say corrosion of magnesium, meaning magnesium undergoes oxidation, meaning they are going to release the electrons. Alright, so what is rusting? Okay, rusting is the term given to the corrosion of iron. Alright, so when iron undergoes corrosion, this process we call it as rusting. Okay, so for corrosion of magnesium, corrosion of zinc, alright, this one we don't have any other terms, don't have special terms. Okay, but for iron, when they undergo corrosion or oxidation, the term given is rusting. Okay, so basically, what you're seeing here in this picture right here, right, this is your rusting, this is your rust, right? Okay, it's basically because of the iron. Okay, and this rust here, meaning the brownish red color thing that you're looking at here, right, is actually your iron 3 oxide. Alright, so basically your iron will undergo oxidation and later on they are going to form iron 3 oxide. So this is what we call rust. Okay, this is the rust, meaning the brown thing here. Okay, that is your rust. Okay, is the iron 3 oxide. So what you're going to learn is how the process, the stages of how do we form the iron 3 oxide or your rust. Alright, so basically for any metal when they undergo corrosion, normally they are going to form the metal oxide coating. Alright, so for example if aluminium, they are going to form aluminium oxide. Okay, so that is the prelude or introduction about the corrosion of metal. Alright, so now I'm going to show you the stages of your rusting. Okay, the rusting process. Alright, the mechanism of your rusting. So you need to know the whole story. Alright, this one can be asked in your SPM paper 2, your essay part. Alright, so you need to know the whole storyline. Okay, so first let us look at this diagram right here. Alright, so basically normally they are going to divide it into 4 stages. Alright, so basically the first stage is the water at the center of the droplet. Center of the water droplet. Alright, center of water droplet. Okay. Alright, so the first part we are going to look at the anode, which is your first stage. Okay, meaning right here. Alright, so one thing that I would like to mention is that in order for rusting to happen, you learn since kindergarten or primary school, right? If rusting needs to happen, it needs oxygen and also water, right? So right now we are going to see how the oxygen and water causes rusting to happen. Okay, so the one in the middle right here, alright, this will be the anode or the negative terminal. Okay, this whole thing is actually a chemical cell, right? You need to think of it as a chemical cell, right? So if it's a chemical cell, your anode is the negative terminal. Alright, so in the middle right here, okay, the concentration of oxygen is the lowest. So you need to remember, alright, in the middle right here or at the anode, the oxygen concentration is low. okay, compared to outside here where you have a lot of oxygen. Alright, so this is your anode. And then remember, if it's anode, what is the reaction? Anode is oxidation. Okay, remember the acronym NOx, red cat. Alright, so oxidation will happen. Okay, so first stage, which is at the center of water droplets, oxidation. Alright, so we are going to have oxidation. Let me use a different color. Okay, oxidation. Alright, so my half equation will be Fe oxidize, and then we are going to release the electrons. Okay, so in the first stage, we are producing the Fe ions. Okay, the iron 2 plus ion. Alright, now after they release the electrons, okay, the electrons will move to the edges of the water. Alright, so during this part, okay, this is your cathode. Right, remember this is a redox reaction, so you must know where is your anode, where is your cathode. Okay, so here, remember if it's cathode, it's going to be reduction. Alright, but we are reducing the oxygen. Okay, so electrons released at the anode will travel to the cathode, meaning the electrons, if you see the arrow here, they are going to move to the edges of the water. Alright, and then the oxygen and the water is going to absorb the electron or accept the electrons to form the hydroxide ions. Okay, so your half equation at the reduction or at the cathode is the reduction of your oxygen. Okay, so if you notice, right, this equation is basically the reverse of your hydroxide. Okay, normally we write hydroxide and then they form this, right? So in the mechanism of rusting, we are just switching the two things. Okay, so okay, remember to balance. This is 4, this is 4. Okay, so this is the second stage. Alright, now third stage will be this. Okay, third stage will be the formation of iron hydroxide. Okay, because anode releases F2 plus, Fe2 plus, and then at the cathode, they are going to form the hydroxide. So these two are going to combine to form your iron hydroxide. Okay, so at this part here, Fe2 plus is going to combine with hydroxide ions to form iron hydroxide. Okay, balance. Oops. Right, and then the final stage of your rusting process, which is the formation of your rust, meaning the brown color thing. Okay, remember for the color of ions, okay, iron 3 is brown in color, right? Iron 3 ions are brown in color. That is why your rust, the color is brown. Okay, so after they form iron hydroxide here, this one will further undergo oxidation to form iron oxide. Okay, Fe2O3. Alright, the one at the behind here, this one is just telling us the number of water molecules that we have in the iron oxide. Okay, so basically what is happening here is that your Fe hydroxide will further undergo oxidation to form Fe2O3. Okay, middle, dot in the middle. Alright, so basically that is it. Okay, I've summarized the whole what they call mechanism into these 4 stages. Alright, so it's easier for you to see. Alright, so first is the anode. Oxidation happens, release iron 2 plus and also the electrons. And then the electrons will travel to the cathode. Alright, because electron will always travel from anode to cathode. Okay, remember that, huh? And then the oxygen will accept the electrons to undergo reduction. Okay, and then the iron 2 plus and the hydroxide ions, alright, is going to form the iron hydroxide. Okay, and then the iron hydroxide will undergo oxidation to form iron 2 or iron 3 oxide. So this is your rust. If it's in the objective questions, alright, if they ask you for the chemical formula of rust or which one is rust, you need to know that rust is your iron 3 oxide. Okay, so maybe I'll just write the name for you lah. So maybe we can iron 3 oxide. Okay, so the color is brown. Okay, so these are the stages of the mechanism of rusting. Okay, so what are the factors that will affect the rusting process? Meaning, what will make the process happens faster? Meaning, what will make the rusting process happens faster? All right. So I'm going to show you two factors. Okay, factors that affect rusting process. Speed of rusting lah. Okay, meaning I want to know if I want it to happen faster, what should I do? Alright. Number one, two things will affect the speed of rusting. Yes, if you have salt or if you have acid. Okay. It doesn't matter whether gas or liquid acid lah, but normally because your metals is exposed to air, right? And then if you have acidic gases, for example, sulfur dioxide or nitrogen dioxide, right, this one will cause the rusting to happen faster. Okay, now why does these two things make the rusting process happen faster is because, alright, your salt and your acidic gases will dissolve in the water. Alright, so when they dissolve in water, they make the water become a better electrolyte. Alright, so why become faster? Okay, I'm writing in a simpler English lah, so it's easier for you to understand. Okay, these two things, alright, will make water will become better electrolyte. Alright, short form lah, faster a bit. Okay, so if you are a better electrolyte, meaning your electrical conductivity will increase, right? Will increase. Okay, so if your electrical conductivity increases, meaning your electron transfer, meaning your movement of electrons from anode to cathode is also faster. Okay, electrons will move from anode to cathode faster. Okay, so if your electrons is moving faster, right, meaning your what you call your chemical reaction is happening faster. Okay, the redox reaction here is happening faster. That is why the rusting will be even faster. Okay, so you need to know this two important things. All right, the factors that will cause the speed of rusting to increase. Okay, one is if you have salt or acidic gases. All right, so if you notice, right, for example, if you are beside the sea, okay, any construction or any metal, if you put beside the sea, right, they will rust very fast, right? If acidic gases, meaning an industrial area, okay, any metals near the industrial area, all right, they are going to rust faster, okay, because of the acidic gases that we have here, all right. So basically, those are the factors that will affect the speed of rusting. Okay, so I have already summarized everything for you. Alright, the mechanism of rusting, okay, the four stages here, and then what will affect the speed of the rusting. Okay, so now that we know how rusting happens, okay, we are going to learn how can we control the rusting process. How do we prevent it from happening? Alright, so the idea is I want to stop the formation of the iron 2 plus. Alright, if I can prevent the iron 2 plus from coming out, or if I were to say in a more technical term, if I were to prevent the oxidation of the iron, I can stop the formation of the iron hydroxide, hence eventually will stop the formation of the iron 3 oxide. Okay, so you just remember the concept. To stop rusting from happening, we cannot let iron oxidize. We need to stop the oxidation of iron. Okay, so how can we do this? All right, there are a few methods. Okay, so the one that you know or in your daily life is what they will do is maybe they will put a layer of oil on top of the metal, or maybe a layer of paint on top of the metal. All right, so this protects the iron from contact with oxygen and also water, so you do not have any oxidation happening. Okay, but the one that I'm going to teach you is about the sacrificial protection, meaning we are going to use different types of metals. Okay, this part right here. Okay, how can we prevent or how to control the rusting process? All right, so the idea here is very simple. Your electrochemical series. Okay, all right. Remember, the one higher is more electropositive. So what we do is we take the iron, we are going to wrap it with either the metals above it or metals below it. Okay, if I want it to rust faster, then I use the metal below it, meaning I take the iron, I wrap it with maybe for example copper, so the rusting process will happen faster. Okay, if I want to stop rusting from happening, I'm going to use metal higher than the iron. Alright, that's why if you look at the sentence here, iron does not corrode when in contact with this one. Okay, and this one is iron corrodes when in contact with this 3 or silver. Alright, and then the further you are, okay, if let's say I corrode, not corrode, if I wrap with tin and copper, alright, so iron with tin, iron and copper will corrode faster because they are further away, right? The further you are, the more reactive it is. Okay, so basically that is the general idea. Alright, if I want to prevent corrosion of metal, alright, or prevent the rusting from happening, I'm going to use metal which are higher than iron. If I want it to happen faster, I'm going to use a lower one. The lower you are, the faster it will happen. Okay, so I'm just going to show you what happens when we use different types of metals. Okay, just to show you the difference of what is happening right here. So let me just bang. Okay. Alright, so the difference will be only in the what they call anode part. Alright, so let's say this is the iron bar. Alright, my iron bar. Okay, and then I'm going to wrap it with, let's say for example, okay, just imagine that I'm a super talented artist, which I'm not. Alright, so let's say if I wrap it with zinc, this is zinc. Okay, so what is going to happen here is at the anode. Alright, so our electrochemical series, if you are higher, you will be oxidized. So when we compare zinc and iron, zinc is higher than iron. So zinc will be oxidized instead of iron. Okay, so the only difference is at the anode. The cathode is still the same. It is still the formation of the hydroxide ions. Alright, the only difference is when, because here I'm forming I'm getting zinc 2 plus ion, right? So at this stage here, I am going to get zinc hydroxide instead of iron hydroxide. Okay, so technically we have stopped the formation of iron hydroxide. Okay, hence they will not get rusting. They will not get rusting, meaning they will not form iron 3 oxide. Okay, so basically that is it. It's a very simple concept. Alright, if I want to stop rusting from happening, I use a metal which is higher than iron, and then I just wrap it with that metal. Okay, why we do that is because the one that is higher in the electrochemical series will be oxidized. So remember just now, if I say if I want to stop rusting from happening, I want to prevent the Fe2 plus from coming out, meaning I want to stop oxidation of iron. So by doing this, we have prevented the oxidation of iron. Hence, iron trioxide will not be formed. So no rusting. Okay, so that is it. Okay, that is how we control the corrosion of metal. Alright, it's a very, very simple concept. Okay, alright, so I'm just going to show you an example of the what they call experiment here. Alright, because you guys are SPM students, right? So you need to know a few important things. Alright, okay, for example, this one. Alright, so when I give you an experiment like this, a few important things that you need to know. Number one is this potassium hexacyanoferrate 3. This solution is to test presence of Fe2 plus ions. Alright, phenolphthalein you already know. This one is to test presence of hydroxide ions. Okay, now if I have iron 2 plus ions in my solution, okay, the potassium hexacyanoferrate will become blue in color. Alright, if there is no Fe2 plus ions, okay, this solution will not change color. Alright, meaning you're only going to see pink color. Pink color is because of what? It's because of the phenolphthalein. Okay, remember phenolphthalein in alkaline it's pink. So alkaline is hydroxide ions. So when you have hydroxide ions, your phenolphthalein will change into pink color. Okay, alright. Now first let us look at the metal involved here. So we have magnesium and paku besi. So funny, this is in BM. Alright, paku besi is iron lah. Okay, so when they give you something like this, right, first thing is you check magnesium, is it higher or lower than iron? So if magnesium is higher than iron, meaning that here no rusting will happen, correct? Remember, if you use a metal which is higher than iron, you stop the formation of rust. So no rusting will happen. If no rusting happens, the color that you will see is this, pink spots, high intensity of pink spots. Okay, this observation tells me that in this solution, I only have hydroxide ions. Okay, no Fe2 plus ions. Alright, since it's only pink. Okay, so that is why you see the inference here, pink color shows the presence of hydroxide ion. No blue spots. Okay, so don't have iron 2 plus. So no rusting. Alright, and then if you want to explain why, it's because, or you always write this in your answer. Okay, magnesium is more electropositive than iron. Always start with this one. Okay, so we release electrons to form magnesium ion, so they undergo oxidation. Okay, oops. Alright. Okay, blah, 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 blah. And then the reduction half equation is still the same. Alright, it's still this one, H2O plus electrons, and then you get the hydroxide, right? So 2, 4, 4. Okay, so here we have stopped the formation of Fe2 plus by using a more electropositive metal. Okay, so let's look at this what they call example right here. All right, so let's look at the this one. This is copper and this is not iron. It's iron. Right, copper is lower than iron, right? So if it's lower than iron, meaning rusting will happen. Rusting occurs. Okay, so if rusting occurs, what is the observation that I will see? This one, blue. Okay, high intensity of blue coloration. Alright, because of the potassium hexacyanoferrate 3. So you need to remember potassium hexacyanoferrate 3 is to test Fe2 plus. If I have Fe2 plus, this one will change into blue color. Alright. Okay, so phenolphthalein is no longer important because the blue color will what they call it is so concentrated that you might not be able to see the pink color anymore. Alright. So high intensity of blue spots shows that you have Fe2 plus. So iron will rust, meaning rusting will happen. So in this case, your oxidation will be the iron. Alright, they are going to form the iron 2 plus, and then eventually they are going to form the iron hydroxide and iron oxide. Alright, so that is it. Okay, that is how we are able to identify whether rusting will happen or won't happen. Okay, so today you have learned three things: mechanism of rusting, how does it happen, and then what are the factors will what they call cause rusting will happen faster, and then you learn about how can we stop rusting from happening. All right, using electropositive metal and less electropositive metal. Okay, so you need to understand the whole storyline right here. All right, so once you understand the whole storyline, it's going to be easier for you to what you call answer your questions. Okay, and then finally is the observation right here. All right, for an experiment, how do we know rusting happens or not? Okay, it depends on the color of the solution. When you have the potassium hexacyanoferrate, if rusting happens, you are going to see blue spots. All right, meaning this one is going to change into blue color. If you only see pink color, meaning inside the solution only got hydroxide ions. Okay, so rusting does not happen. Alright, so that is it for your whole rusting process. Okay, so I hope that this will help you to understand better about the mechanism of rusting and the prevention method. Alright, so I believe that is it for today. I will see you again in the next part of your Redox. Bye.